Looking at solving linear equations symbolically, the simple equations were expected to know at this point. This being college algebra, we assume that the basic idea of moving terms by adding and subtracting and then multiplying or dividing both sides by a number in order to get x alone is a very familiar process. So we'll just review one of the harder kinds of equations that shows up, such as these equations involving fractions. In this example, each term has a fraction in it, and if we start by looking at all of the denominators, we can find the lowest common denominator, which we refer to as the LCD. The smallest number that's a multiple of 3, 6, and 2 is the LCD, and in this case that would be 6. Sometimes people come up with 12 or 18 first. If you use a number that's bigger, it'll still work, but it's going to make all of your numbers bigger along the way. So the smallest number possible is our goal. What we're going to do is called clearing fractions, and the way we do that is by multiplying both sides of the equation by the LCD. So here's what that looks like. I'll take that 6 and I'm going to multiply it by the whole left side, and I'm going to take that same 6 and multiply it by the whole right side. So the left side looks like 2/3 x minus 1/6. We have an equals in the middle here, which is why we're allowed to do this. It's a balanced operation on both sides as long as I multiply the whole side of the equation. This is legal. And I'm going to distribute the 6 into both terms on the left because I have two separate terms here. On the right-hand side, I can see the whole thing is divided by 2. So on the right-hand side, it's safe to do a little bit of cancellation right away. Remember that we can think of that 6 as being a 6/1. So the 6 is really in the numerator, and that factor of 2 can cancel with the 2 in the denominator. So that leaves me with just a 3 to distribute into the right-hand side. Everything is now gone from the denominator. I need to be really cautious not to do that kind of canceling over here on the left, because 6 gets multiplied by 2/3 x, and the whole 6 gets multiplied by 1/6. If I do that sort of canceling with pen right now, then there's a reasonable chance that I'm going to make a mistake. So I'm going to write this out the long way. That's like 6/1 multiplied by 2/3 x minus 6/1 multiplied by 1/6. And on the right-hand side, I'll go ahead and distribute. 3 times 3x becomes 9x, 3 times 5 becomes 15. Now that I have these written as individual products, it's safe to go ahead and cancel. The factor of 3 drops out and leaves me with 2. The factor of 6 drops out and leaves me with just a 1, the multiplicative identity 1. So now I can see that what I have remaining in the first term is 4x. What I have remaining in the second term is just 1. Everything is multiplied 1/1. And on the right-hand side, I have 9x plus 15. So this is a somewhat longer than necessary way of clearing the fractions. I'll just mention really quickly that a little bit easier way to get this would be to think about in this first step here when we're multiplying 6 by 2/3 x, it's okay to multiply the 6 by the numerator 2 and then divide by 3, right? 6 times 2 gets me 12, divided by 3 gets me the 4 that I have down here. Then do the same thing with the 6 and the 1/6. 6 times 1 gets me 6, divided by 6 gets me 1. So you can do this without writing out that kind of in-between step that we put here, but you do want to be very careful because it's really common for me to see this. 6 cancels with 6, and then somehow we lose the 6 from one of those two products. So that's what not to do. All right, now that we're down to a simple linear equation, we can get all the x's on one side, get all the numbers on one side, and go ahead and solve it. So maybe I will move this 1 over to the right by adding it, and I'll move this 9x over to the left by subtracting it. Doesn't really matter which side we move them to as long as we get all of our x's together on one side. We've got a negative 5x now on the left, and we have our numbers together on the other side. So divide both sides by negative 5, and we end up with x equals negative 16/5. We don't want to leave that negative in the denominator. That's very sloppy. We should figure out whether the number overall is positive or negative. Another way to write this, by the way, is in set notation. You'll see answers written this way a lot in the book, and you'll probably be asked for answers like this in your homework. So as long as your answer is clear, it's probably fine if I'm the one grading it. But just so you know, both of these are expressing the solution set. The first is a statement that x is equal to negative 16/5. The second way of writing it is that the solution set consists of only the value negative 16/5. To check an answer, if you have a lot of fractions, you might want to go with a decimal version. In this case, we have an exact decimal version, x is equal to negative 3.2. In some cases, you may need to try with a decimal approximation. For our actual work, converting to a decimal is generally not what we want. We want exact values, and a lot of the time we have to leave them as fractions. But for a check, when all we're doing is trying to convince ourselves that we've done it correctly or catch an error if one might have occurred along the way, a decimal approximation and then plugging into the equation as a decimal approximation is a reasonable way to do that. So in this equation, we can take 2/3 as 2 divided by 3 times 3.2, which will make negative. And from that, we will subtract 1/6, and we can see that we get about negative 2.3 on one side of the equation. Maybe writing that down. And clear out of this. Let's go ahead and do the other side. 3 times 3.2, which I'll make negative. Then I add 5. And then I divide the whole thing by 2, and I can see that I get exactly negative 2.3 this time. If I had to do a little bit more rounding on my answer or anywhere along the way, I wouldn't expect the two sides to come out to be exactly the same, but usually if a mistake is made somewhere along the way, they'll be way off. So if they come out very, very close, that's a good sign.